So, do you know the advantage of being a technician is that you can get technology at a cheaper price, but just has to be a scrap. So I got this inverter of 250 amp, 60 volts from a welder as a scrap. He told me that he will use the part whenever he goes to fix inverter. They will tell him that okay, they don't have the part of the inverter and they can't fix it, so he will give them this one for them to remove scrap from inside. That's what he told me, and I said okay, you should sell this one to me. And he gave me this one for 5,000 naira. Look how beautiful it is. And he wanted to scrap this baby. Can you imagine? Using an IC, a UC IC to power the whole system, and now I have been able to fix it. I bought the inverter for 5,000 naira. Once I connect it to power, the bulb flash because of the big capacitors that are there. And once the bulb is this thing is charged, and the light is not allowing you to see the okay. Now the inverter is on now. There's voltage output. This is the current. I can vary the current from 15. I reduced it to 170, and this is the highest you can go, 170. It was 250, but I'm not working on heavy stuff, just some house appliances, some house welding that I'm planning to do, and my own stuff that I'm building. So this is my voltage outputs. Let me show you how this baby work. And here is our voltage. So let me just switch the probe so you can see it. Here's our 60 volts. And the whole system is okay. If I overheat the system, this stuff, the thermistor, we shut down the whole system, and everything is okay except there is no heat sink for the IGBT, which is so bad. And I didn't realize it at first that the IGBT normally get hot, and I was sparking the inverter, creating the arc, and that was when I noticed that okay, I will need to stop and test. That's when I noticed that the IGBT was getting hot because of the lack of heat sink and also fan. There's no heat sink and there's no fan. If you've ever repaired a welding machine, you will know that what I'm doing is dangerous. I can literally blow out the IGBT due to its body heat. So that's very bad. And the whole system is a half bridge topology. You can see the capacitors store the energy, and these other capacitors here are what splits the voltage and then supplies to the transformer. We only have two diodes here. I think they are of 60 amp each. Yes, they are of 60 amp, 3000 voltage, and these are the low voltage power supply. That is the 12 volt power supply. But the downside of this inverter is that it doesn't have a startup capacitor and a load resistor. There's no load resistor on it. So if I put the inverter, if I connect it to lights, the bulb instantly light up too much. That's why I know the inverter will make arc once you connect it, because it's very easy to figure that out. Sure. So you see, the bulb lights up very well, and now the inverter is live working. So you will know that okay, this bulb that lights up, it will be an arc. At even there's a load resistor, it will reduce the brightness of the bulb, giving the capacitor time to charge before switching the whole system on. So, but since there's no resistor and there's no relay to make that system I think it will be very bad for this most for this IGBT, which means I may have to reduce this capacitor because I increased the capacitance. One of this, I increased the value of this one, which means I have to remove this one. So the system will work with this one. I'm using it for housework. I will even still need to reduce the currents, and that's how you fix a scrap or a dead inverter, bring it back to life. So what I did was I had to fix the gates chopper. The system here was corrupt, was badly damaged. First of all, I took this inverter, I washed it thoroughly with soap to make sure that there is no partial contact on this board. I washed everything with soap, so any partial contact that was going on that is limiting the signal or causing spike or whatever kind of disruption is making on the frequency and the system, I washed all the contact out. After washing it, I allow it to dry. Then you can see how the epoxy, the resin for protecting the uh, PCB, how thick it is. Then I had to start fixing this. After fixing it, I put a new set of IGBT. I think all in all, I got this inverter for, let me just say, 7K, 7,000 naira. And if I'm about to sell it now, we have to sell it about 30,000 naira. Yep, I think 7K. Should we calculate? Okay, the inverter 5,000 naira. It is to it's about 800 naira. 800 naira. Then the resistors, I think there should be about 200 naira because I use 1, 2, 3, 4, 5, 6 resistors and 2 diodes, and I fixed the whole thing back. You can see how they all worked out pretty well.